This is the video for Build the Gray Data List. Over here on the top left is the routine that builds the list. Over here on the right is part of that list. Down below here is some of the data that it will need to build the list. For instance, here is price for each one of the 8 items. Over here are the requirements for each one of the 8 items. There are 8 parts, and it can have a requirement for each one of those 8 parts. Well, now we'll start through the routine. It sets binary value to 1, sets H to -1. See, set negative. Sets L to 20, and then it says for I of 0, down here the next I and G, where N G is the number of bits there are, 1 at a time. Well, the first time around, it's going to have bit item 1 and bit factor 1. So it sets R to the bit item sub I, the ith one, sets F to the factor for the ith one. Then it sets negative G, well actually it sets G to negative F. Then it sets NS, which is control register, to the value of 8. That's going to be used down here by both convert column to row and this multiply list instruction. They both need to know the value of the control register. It's set to 8 because that's the number of parts there are. The next thing it does is it starts to build a list called hold list. First value in that list is going to be the price of the item. Remember, R refers to which item this is. Then it multiplies that value by F. That's the factor. So if the item is brought in 1 time, it multiplies it by 1. If the factor is 2, it multiplies it by 2. And for instance here, if the price is 5, the first one will be 5. The next one will be 10. Right, so then it does that. Then it also moves into hold list at offset 1, the binary value. Remember, we first started out at 1 up here, but every time it goes around for another bit, it doubles the value of binary value. That means it's going to be 1, 2, 4, 8, 16, 32, and so forth. That will indicate in the answer which ones are in the answer and which ones are not. So we'll be able to figure out what the solution was. This is dynamic programming, and we need to know how we got to the answer. Right, that's the binary value. Now here's where it's going to take the requirements for the rth item, and that will, here are the requirements down here, and move it into a list called row list. This offset 20 refers to the fact that these values are actually 20 apart in the memory of the computer. So it has to know how far apart they are. It also had to know up here that there are 8 of these requirements. Well, it builds that row list. Then down here, it multiplies G times that row list to give 8 values at offset starting at 2 in the hold list. So the hold list, we'll see over here, contains, well, 8 and 2, 10 different things. And here it says move numerically 10 values to gray list plus L from the hold list. There are 10 values that it generated, and we're putting them in the hold list. That's over here. Then it sets the control register and S to 10, because now it's going to multiply all those values that it had up here in hold list by H, which is a -1. And then it's going to store them in the gray data list at offset 1000 plus L. So here, this one's at 20. At 1000 plus 20 is exactly the same values, but the opposite sign. They'll be negative. Then here we see where it doubles the binary value, and here it increases L by 20. So first it's doing this one at 20. That's where it puts the whole list. The next time it puts it at 40, 60, and 80, and so forth. Well, let's go over here and see some of the data that it generated in our grade data file. All right, here at offset 20, the first one it made, it said 5. All right, that's the price of it. 1, that's the binary value indicating that this is the one in the solution. And then it has as negative all the requirements for 1. And then at offset 40, which is the next one it's going to make, where it puts whole list, it's 10 because it's in the solution twice. 10. And its binary number is 2. And here we see the minuses are all twice what they were for when it was in 1 time. The next one, though, is when it is in 4 times. So it's 4 times 5. Its binary number is 4. And now the requirements are 4 times what they were when it was 1 time. And then the next one down here is 8 times. 40 it is. 5 times 8 is 40. Its binary number is also 8 because it's in order. And it has 8 times the requirements. So this is how it works. If this is the only one of them in the solution, that is all it found in binary 1, it says 5. However, if it was in twice, it would use this one and say, oh, okay, it's 10. If it was in 3 times, it's going to be this one will be in the solution plus this one. 1 and 2 make 3. If it's in the solution 4 times, it's going to use this one. 4. If it's in 5 times, it's going to be 4 and the first one 5. And so forth. In other words, it's the binary values here, and it's going to make all the possibilities up to 15. If you look down here on the lower left, item 1 can have as many as 15. Well, that would indicate that 1, 2, 4, and 8, they add up to 15, are all in the solution. All right, this is the end of the video for Build the Great Data List.